Welcome to an example in which they're giving us this big polynomial right here, which is x to the fifth, 3x to the fifth, and then all the way down. And they're telling us that 3i is a 0 and that one of the x-intercepts is -3. And then they're giving us a hint. Find all the zeros, they say, and list them separated by commas. Hint, since 3i is a 0, -3i is also a 0. So it turns out whenever you have an imaginary 0, you have the opposite sign called the complex conjugate, which I'll just leave it at that. The opposite sign is also a 0. Okay, how are we going to, this is a hard problem. By the way, here's all the answers, but of course we don't always have that in the test. So how did they come up with that? Why are those the answers? Well, basically we have x to the fifth power. That means we got to start breaking it down. We got to divide by the -3, because they told us that's one of the x-intercepts. That'll bring it down to the fourth power. Then 3i, that'll bring it down to the third power. And then -3i, that'll bring it down to the second power. And once we get down to the second power, we can do the quadratic formula to find the last two. That's basically the game plan. Let me show you in the notes. So in the notes, it says if you've got a function and they give you one of the zeros here, you do synthetic division and you get your result right there. And eventually you're going to do the quadratic formula once you've got it down to x squared. So this one's going to be harder. Let me start with actually a graph of this thing. Here's the question: 3x to the fifth, on down. Well, I've actually got I can show you the graph. There it is on Desmos.com. I've graphed it, and you can see the graph here. It's so if I make it smaller, well, it goes really high. Huh? All right, so it goes really high and really low, but you can see the three places it's crossing the x-axis right there at -3 and right here at 2. And this one is hard to tell exactly what it is. So look at the graph on Desmos.com. It's hitting the x-axis in three places: -3, and then 0.667 and 2. You might recognize that 0.667. That's actually 2/3. Like 1/3 is 0.333 and 2/3 is double that, 0.666, and you round up the last digit to a 7, 667. So that's basically -3, 2/3, and 2. So, but then there's two other ones which are imaginary, 3i and -3i, which they told us about. Those are the 5 zeros. Now, we don't all have a graphing calculator we can use during the exam, but I just wanted to show you that's a picture. Three of the places it hits the zero, three of the x-intercepts, three of the zeros we call them, three of the roots, goes by any of those names, are right there. They're places it hits the x-axis. The other two are imaginary, so it's not real places it hits the x-axis. But anyway, I want to show you that picture. Let's get to business. How do we do it? So step number 1, synthetic division by the -3. Because that's just take the first one they gave you. So here we go. So I'm going to do synthetic division. I'm going to grab that -3 right over there. And I'm going to bring these coefficients down. This 3 coming on down. This is a 1 here. Coming on down. This is a 7. 21. -180. Oh, wait. It's a long one. There we go. All right. Remember how synthetic? So be careful with this. It's easy to make a small mistake. So here we go. Bring down the 3. And then here we go. -3 times 3 is -9. And you add these up, and that comes out to be -8. So add those up, right? -8. And then you do another one. -3 times -8. Put it right there. It'll be plus 24. And then you add these up, and you get what's that? 31. And then you do another one. -3 times 31. You put it right there. What's it going to be? Negative 93. Add these up, and you get -72. And you go -3 times that. Numbers are getting big here. So that be two negatives going to be positive, huh? Positive, you put it right there. Positive at 210 and 6, 216. 210 and 6. Yeah, 216. Okay, and then we're going to add these up. So that'll be what, 36. And then the last one, -3 times that, right there. Look at that, -108. Look what that happens, add them up, 0 remainder, of course. So that means it goes in perfectly. You should always get a 0 remainder because that means it went in perfectly. Okay. So what's left? So it's like we just took a big old number, like let me see, like 210 or something. Like if I gave you like 210, I said start breaking it down. We just divided by whatever, like 2, and got 105. And then that's done. We're gonna break that down further. That's the kind of thing we're doing here. So okay. So what's left over? Well, we started with x to the 5th, didn't we? Right there. That's x to the 5th. So that means this answer is x to the 4th. Minus 8x to the 3rd plus 31x to the 2nd minus 72x to the 1st plus 36. That makes sense, the leftovers, because you're always going to go down by 1 degree when you divide. So if we started with x to the 5th and we divided, right? Dividing makes things smaller. So you start with x to the 5th. When we divide, the answer will be x to the 4th. So there's what we got. So then step 2 is going to be synthetic division again, this time by, what's another 0 we know? Well, they told us 3i is a 0. So now I'm going to do 3. And now it's going to be tricky because it's imaginary. All right, so here we go. Going to do it again, round 2. So, and I'm going to bring down these coefficients. So let me first actually grab the 3i right over there. 3i, and I'm going to bring down the coefficients. So right here, 3, let me give some space here. -8, 31, -32, 36. There we go. So bring down the coefficients. Now divide by 3. Now we have to be really careful. So bring down the 3. And here we go. 3i times 3. What's that? Well, it goes right there. It's 9i. And then you add these. So what are you going to get? Well, you're going to get -8 plus 9i. You can't add those. You can't go 9 minus 8 is 1 because this guy is a regular number and this guy's imaginary. They're unlike terms. It's like having a -8 and a 9x, right? They can't add together. One's just a plain old -8. The other's got an imaginary part. So it's a complex number that has a real and imaginary part. And then we do our next step. So this 3i is going to go boom, boom, hit them both, and the answer is going to go right there. So 3i times -8, what is that? It's -24i. And 3i times 9i is -27. Let me help with that. Probably you're a little confused by that. Yes, in fact, I need more room too. Let's get so -24i minus 27. So you're probably wondering where'd that minus 27 come from? Excuse me. Let me go over here and show it. So if you're going to take 3i and you're going to multiply by 8 or -8 plus 9i. That's what I just did, right? I just took the -3i and it's going to multiply it -8 plus 9i. Let's do it over here. So what's going to happen? So boom, boom. So 3i times -8, that's pretty easy, -24i. And 3i times 9i is plus 27i squared, isn't it? Right? Because 3i and 9i, 3 times 9 is 27, and I times I is I squared, just like x times x is x squared. Now the question is what happens from there? Well, I don't know if you remember, but I squared, we never leave I squared. It's -1. So that's really important that you know that. Maybe it's been a while since you've seen that or something. But I squared, we never leave I squared. I squared is -1. Regular I just stays regular I. We don't mess with that. Regular I just stays regular I. But I squared, that becomes -1. We replace it with -1 because it is -1. I don't want that to be magic. Think with me for a second. what would be the easiest way to show you that that's true? You know, here I can prove to you. You know that the square root of 9 is 3. And what's the square root of -9? Well, the negative comes out, right? And it's I, and then square root of 9, and so that's 3I. Right? So when you have a negative inside, it's just puts an I there, doesn't it? So what's the square root of -4? Well, the negative comes out. It's I square root of 4, so it's 2I, right? So then what's the square root of -1? The negative comes out, square root of 1, so it's -1I or just -I. So, wait, I'm sorry. I was so dumb. Let me try that again. What am I doing? The negative comes out as an I, and the negative's gone, right? I square root of 1 I, or just I. So my point is I is the square root of -1. Do you see that? I is the square root of -1. Okay, so what? Well, then if I is the square root of -1, what is I times I, which is I squared? It's square root of -1, square root of -1. And what's that? It's just -1. Remember square roots, what they always do? 2 in, 1 out. So it's just -1. So there's my proof that I squared is just -1. I squared is just -1. All right, so whether you buy that or not, whatever, let's get back to the problem. So this I squared right here is just -1. So this becomes -24I plus 27 times -1 is -27. That's how I got this right here. All right, back to the problem. Now add these together. This guy and this guy will combine. Let's put them in the front. So that'll be, what? 4, right? 31 minus 27 is 4 minus 24I. All right. Now the 3I is going to go boom, boom, and hit them both. What's that going to look like? Well, kind of running out of room for doing all this crazy monkey business. So it's going to be, maybe I'll put it down here where I scribbled all this stuff. Just proving to you that I squared is -1. Okay. So coming back here. So I don't even know where to put it. So maybe I'll put it right up here. I just erased everything and I'll put it somewhere else. I don't know where to. So, all right. So let me show it to you. So we're doing 3I times 4 minus 24I. So let's do it up here. So 3I times, what was it, 4 minus 24I? 4I, here we go. Boom, boom. 3I times 4, that's easy. That's 12I. 3I times minus 24 is minus 72I squared. But remember, we never leave I squared. What is I squared, as we proved a minute ago? It's -1. We leave regular I as regular I, but I squared we replace with -1. So then this becomes 12I plus 72, because -1 times -72 is positive. So that's what we get there. Right there, we're going to get 12I plus 72, you see. And then when we add these together, minus 72 and plus 72 will cancel, and you'll just get 12I. Last step, 3I times 12I is 36I squared, which is minus 36. Is that okay? 3I times 12I, 3 times 12 is 36, and I times I is I squared, but we never leave I squared. That is -1, and 36 times -1 is -36, hence the -36. Add them up, 0. We always get a 0 remainder. You got to get a 0 remainder. If you don't get a 0 remainder, you messed up. Okay, but where in the world does this leave us? Well, in a big mess. So now this means we're gonna do one more synthetic division, but I'm just gonna go right into it. So one more synthetic division. Synthetic division by this time minus 3I, right? They told us, right? If you look back to the beginning of the problem, they gave us the hint. 3I is a 0 and minus 3I is a 0. So we can divide by both of them. So now I'm gonna do the minus 3I. And that's going to be a big pain also, which I'm sure you're very excited about to hear. All right, so I'm going to take these coefficients, 3, and this one, which is minus 8 plus 9i, and this one, so I'm just grabbing these coefficients, 4 minus 24i, and this one, so 12, whoops, 12i. Okay, this is a long problem. All right, what's going to go out here is the minus 3i. Here we go. Bring it down, 3. All right, let's multiply that. Minus 3i times 3 goes over here to be minus 9i, right? And then add these up. Yeah, these cancel, don't they? Just minus 8. Then minus 3i times minus 8 goes right there. That's going to be what? Minus times minus is plus 24i. This is working out very nicely. This one's much nicer. Add these up. These cancel. And we just get 4. This is beautiful. And then minus 3i times 4 is minus 12i. Look at that. Add these up. 0 remainder. Always look at that. All the imaginary stuff went away. We just got these. What degree are we at now? Well, this is x squared. 3x squared minus 8x plus 4. How do we know? Well, because every time we divide, we go down 1 power. So we started at x to the 5th, did our first division, and that left us x to the 4th. Then we did 2 more divisions, and that brought it down 2 more levels from x to the 4th all the way down to x squared. So now, final step, step 4, we're almost there. You do the quadratic formula on 3x squared, because now we're x squared. Once you get to x squared, oh, did I write x squared in the second one? It's dumb. Right, 3x squared minus 8x plus 4. Like that, it always goes down a level. 2, 1, no x. So do the quadratic formula. You remember the quadratic formula. Let's do it. Boy, it's a long one. So we're going to go there. Write that here. And put it right there. And put it right there. Plus and minus. Okay. Here we go. This is A, B, C. Negative B. So I'm going to go, okay. Negative, and then B is negative 8, huh? Oh, wait, I'm supposed to write it out first. Sorry. Let me first write the formula. So its formula is negative B plus minus square root of B squared minus 4AC all over 2A. Almost got that thing memorized by now, maybe? All right, so negative B. So negative B. B is negative 8. There. Negative B plus minus square root of B squared minus 4 times A, what's A? 3 times C, which is 4, all over 2A, what's A again? 3. All right, so now coming on down here. Where are we at? So this part here. Negative, negative 8. 2 negatives, positive 8. Plus minus square root of B squared, that's be 64. Now minus times plus is going to be minus. Use your calculator there, 16, 48, I think. 12, so yeah, all over 6. And so that gives us something, getting closer. It's going to be 8 plus or minus, and this will be the square root of, and what is that? What's under there? So far, I said 2 be 50, 12, 16 over 6. Right, 58 for 964. Yeah, okay. And so, yeah, that's coming apart really nicely. And so that's 8 plus 1. What's the square root of 16? 4, huh? Over 6. So that's 8 plus 4 over 6, or 8 minus 4 over 6. So that's 12 over 6 or 4 over 6. And so reduce that, that's 2, right? 12 over 6 is just 2. This one divide top and bottom by 2, and that's 2/3. So there they are, the other zeros. My goodness, what a lot of work. So then when all is said and done, which it is now, the zeros are, so from the beginning, they told us that -3 was a 0, and 3i and -3i. So -3, 3i, and -3i were zeros. So that's what we divided by. So we got -3, +3i, -3i, and now 2 and 2/3. Right? Did I do that right? That was -3, huh? Wasn't that -3? Back to the top here. Yeah, -3, 3i, and -3i. So there we go. So negative, and you don't need to put the plus here. You could just say, just 3i. So I do that so well. I did the same, all right, whatever, good enough. So -3, 3i, -3i, 2, and 2/3. Those are all the zeros, which is what we saw on the graph. Remember, when we looked at the graph, we saw that, in fact, it went through -3, 2, and 2/3. If we go back here to the graph, say it's going through those spots, -3, there's 2/3, and there's 2. Now, if you just have a graphing tool like Desmos, it's a lot easier, huh? But instead, we had to do a bunch of long division to do it all. So again, what did we do? We just basically divided by all 3 of these zeros that they gave us. So back to the beginning again, that was a long, terrible one. We took the original polynomial, did synthetic division by we started with the real, the -3. We didn't want to get the I stuff in there right away. Did the -3, got this result, stuffed it into another synthetic division with the 3i, got this terrible result, stuffed it into another synthetic division with the -3i, and all the I stuff. Every time we're getting a 0 remainder, that means we didn't mess up. Every time you get a 0 remainder, you didn't mess up. Then these 3 that were left was just x squared, x, no x. So we could plug it in. Once you're down to x squared, then you can use the quadratic formula, which is made to solve any x squared equation. Plugged into the quad, worked it out, got 2 and 2/3, the other 2 zeros. And so there we go. Just as easy as pie. Just as easy as that. There we go.